Geometry is the branch of mathematics that studies shapes, points, lines, and surfaces. Let's start with an example. In triangle ABC, point D divides side AC so that the ratio of AD to DC is 1 to 2. Let E be the midpoint of BD, and let F be the point of intersection of line BC and line AE. Given that the area of triangle ABC is 360, what is the area of triangle BF? For our first step, we can extend line BD and make a new point G. This creates two pairs of congruent triangles. Because line AD is 2 times as long as line DC, triangle BDC is 4 times as large as triangle ADG. If you don't understand, you can look at the bottom right corner where I split triangle BDC into 4 parts. From this information, we can also find that triangle CBD is 240, which means that triangle ADG is 60. The parallelogram below is divided into 4 equal sections, so triangle ADE also has an area of 60. Since line ED is equal to line DG, and triangle ADG is equal to triangle ADE, triangle BFE must be 4 times less than triangle BF, as shown in the figure below. So, triangle BF is equal to 30, which is our answer. Here's our next problem. Point E is the midpoint of side CD in square ABCD, and line BE meets diagonal AC at F. The area of quadrilateral AFED is 45. So what is the area of ABCD? This problem shows that seemingly hard problems don't always have very complicated solutions. In many geometry problems, setting a variable to the smallest shape will help towards the result. In this case, with x being triangle ESC, we can write many equations. So, if we add quadrilateral AFED and triangle EFC, we get 45 plus x. This is exactly half of the square ABCD. Now, if we multiply that by 2, the area of the square is 2x plus 90. Now, we also know that triangle ABF and triangle CFE are similar. So, with ABF having twice all dimensions, ABF is equal to 4x. Now, for BFC, all you have to do is subtract 5x plus 45 from the total area of the square, and that is equal to negative 3x plus 45. We can write one last equation to solve for x. Before we write the equation, we have to first realize that quadrilateral ABED is 3 times as large as right triangle BEC. So our equation is 45 plus 4x, which is the area of ABED, is equal to 3 times the triangle's area, which is negative 2x plus 45. After expanding the right side, we can simplify and get x is equal to 9. Now, because we already know that the area of ABCD is 2x plus 90, we can just plug x in, and 18 plus 90 is equal to 108, which is our answer. Okay, we've done some challenging geometry problems. However, the ability to solve problems fast is just as important as knowing how to solve them. So, for the next few problems, the problems are easier, but we have to answer them fast. Rectangle DEFA below is a 3 times 4 rectangle with DC equal to CB equal to BA is equal to 1. The area of the bat wing shaded area is... This problem can be solved easily by making a 3 times 4 grid over rectangle ADEF. We can subtract the 4 triangles to get the shape. First, we subtract the triangles in green, which, because each have an area of 2, subtracts 4 from the 12 of ADEF, so trapezoid ECBF has an area of 8. The area of the blue triangle, using the triangle formula, is 3 times 3 divided by 2, which is 4.5. The area of the red triangle is 1 times 1 divided by 2, which is a half. So if we subtract that from the trapezoid, it's 8 minus 5, which is 3. A triangle with vertices as A is equal to 1, 3, B is equal to 5, 1, and C is equal to 4, 4 is plotted on a 6 by 5 grid. What fraction of the grid is covered by the triangle? This problem has a really quick and neat solution. You can first notice that you can cut and rearrange the triangles into a square, as I shown on the picture to the left. Each side of the square, using the Pythagorean theorem, is square root 5. Therefore, the area of the square is 5. Also, the area of the big rectangle is 30. So, our answer is 5 out of 30, which is 1/6. 1-inch squares are cut from the corners of this 5-inch square. What is the area in square inches of the largest square that can fit into the remaining white space? This problem is much easier to solve when drawn out. Finding the area of the gray square in the middle looks really complicated, but if we draw 4 lines shown in yellow, it's much simpler. The 4 yellow lines splits our square into 4 right triangles and another square. The area of the square is 9, and the area of each triangle, using base times height divided by 2, is 1.5. So the area of all these 4 triangles is 6. So our answer is 9 plus 6, which is 15. A ball with diameter of 4 inches starts at point A to roll along the track as shown. The track is comprised of 3 semicircular arcs whose radii are R1 equals 100 inches, R2 is equal to 60 inches, and R3 is equal to 80 inches, respectively. The ball always remains in contact with the track and does not slip. What is the distance the center of the ball travels over the course from A to B? The easiest way to solve this problem is to write out the path where the ball will travel as indicated by the red line. The diameter of the first arc is 196 inches. Because 200 minus double the radius of the ball is 196. To get the distance of the first arc, it's just a semicircle, so we take the circumference and divide it by 2, which is 98 pi. For the second one, we do a very similar way, but we add 4 instead of subtracting 4, because this time it's outside. For the third one, we do it very similar to the first one. So if we add all these together, we get our answer, which is 238 pi.